Curvilinear coordinates. Spherical coordinates. Now, to represent a point P, we can use Cartesian coordinates x, y, z. Most of the cases that will be simple too. But for some particular cases, it is more convenient to use spherical coordinates r, theta, phi, where r is the distance of the point P from origin. This angle theta is called the polar angle. This angle phi is known as azimuthal angle. In the figure, r cap, theta cap and phi cap are the directional unit vectors. Now, let's discuss the relation of spherical coordinates with Cartesian coordinates. The Cartesian coordinate x equal to r sin theta cos phi. This is the first relation. Y is equal to r sin theta sin phi. Z equal to r cos theta, where r, theta, phi are spherical coordinates, x, y, z are Cartesian coordinates. By this relation, we can relate both of them. Now, the infinitesimal displacement dl in spherical coordinates is given by dl equal to dr r cap plus r d theta theta cap plus r sin theta d phi phi cap. The infinitesimal volume element d tau can be written as d tau equal to r squared sin theta dr d theta d phi. Now, vector derivatives in spherical coordinates. The first thing is the gradient. Grad t or del t in spherical coordinates is given by del t equal to dot t by dot r cap plus 1 by r dot t by dot theta theta cap plus 1 by r sin theta dot t by dot phi phi cap. Next case, divergence. Divergence of v del dot v equal to 1 by r square dot by dot r square vr plus 1 by r sin theta dot by dot theta sin theta v theta plus 1 by r sin theta dot v phi by dot phi. Next vector derivative is the curl. The curl del cross v in spherical coordinate is given by 1 by r sin theta into dot by dot theta of sin theta v phi minus dot v theta by dot phi r cap plus 1 by r into 1 by sin theta dot vr by dot phi minus dot by dot r of r v phi theta cap plus 1 by r into dot by dot r of r v theta minus dot v r by dot theta phi cap. Now, the Laplacian del square t is given by 1 by r square dot by dot r of r square dot t by dot r plus 1 by r square sin theta dot by dot theta sin theta dot t by dot theta plus 1 by r square sin square theta dot square t by dot phi square. Now, cylindrical coordinates. The cylindrical coordinates can be represented by s, phi and z. Some of the books they are using rho instead of s. That means instead of s we can use rho also. That means rho phi z. Let s phi z or rho phi z be the cylindrical coordinates of the point P. Now, this s is the distance to P from z axis. S is the distance to P from z axis. The relation to Cartesian coordinates is given by x equal to s cos phi, y equal to s sin phi, z equal to z. The infinitesimal displacement dl is given by dl equal to ds s cap plus s d phi phi cap plus dz z cap. The volume element d tau equal to s ds d phi dz. Vector derivatives in cylindrical coordinates can be discussed as follows. The first case, the gradient. Gradient t in cylindrical coordinates is given by dot t by dot s cap plus 1 by s dot t by dot phi cap plus dot t by dot z cap. Divergence del dot v equal to 1 by s dot by dot s vs plus 1 by s dot v phi by dot phi plus dot vz by dot z. The curl del cross V equal to 1 by S dou Vz by dou phi minus dou V phi by dou Z S cap plus dou Vs by dou Z minus dou Vz by dou S phi cap plus 1 by S dou by dou S S V phi minus dou Vs by dou phi Z cap. Laplacian del square t is given by 1 by S dou by dou S of S dou t by dou S plus 1 by S square t by dou phi square plus dou square t by dou Z square. Now, divergence of r cap by r square. Consider a vector function vector v equal to 1 by r square r cap. Now, we have the equation for del dot v, that is del dot v equal to 1 by r square dou by dou r of r square vr plus 1 by r sin theta dou by dou theta of sin theta v theta plus 1 by r sin theta dou v phi by dou phi. ഇനി നമ്മുടെ ഇക്വേഷൻ വിയുടെ ഇക്വേഷൻ നോക്കുക, വി ഈക്വൽ 1 by r square r cap അഥവാ r capന്റെ ടേം മാത്രമേ ഉള്ളൂ. അപ്പോൾ ഡൈവർജൻസ് കൺസിഡർ ചെയ്യുമ്പോൾ സെക്കൻഡ് ആൻഡ് തേർഡ് ടേം ഇൻ ദ ജനറൽ ഇക്വേഷൻ ക്യാൻ ബി നെഗ്ലക്റ്റഡ്. ദാറ്റ് ഈസ് ഡെൽ ഡോട്ട് വി ഈക്വൽ ടു 1 by r square dou by dou r of r square vr. ഇതിൽ 1 by r square dou by dou r of r square into vr ന് പകരം നമ്മൾ ഇത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക, 1 by r square എന്ന് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യും. സോ ദിസ് ഇസ് ദ ഇക്വേഷൻ. ഇവിടെ r square ക്യാൻസൽ ചെയ്തു പോകും. So this equation will be 1 by r square dou by dou r of 1 എന്ന് വരും. 1 is a constant. Constant ഡെറിവേറ്റീവ് എടുത്തു കഴിഞ്ഞാൽ that will be 0. That is del dot v equal to 0. Next, Dirac delta function. ഇത് നമ്മൾ കഴിഞ്ഞ ചാപ്റ്ററിൽ തന്നെ വളരെ വ്യക്തമായിട്ട് ഡിസ്കസ് ചെയ്തിട്ടുണ്ട്. Next topic, theory of vector fields. First case, Helmholtz theorem. According to Helmholtz theorem, a vector field F in electrodynamics can be completely determined if the divergence del dot F is known, the curl del cross F is known, and if the field goes to 0 at infinity. അഥവാ a vector field function F that may be electric field E or magnetic field V that can be completely determined if we know the divergence and curl of that field. അതിനെ നമ്മൾ വിളിക്കുന്ന പേരാണ് ഹെൽമോൾട്ട്സ് തിയറം. നമുക്ക് ഡൈവർജൻസ് ഓഫ് എഫും കേൾ ഓഫ് എഫും അറിയാമെങ്കിൽ വി ക്യാൻ ഡിറ്റർമൈൻ എഫ് അക്യുറേറ്റ്ലി. നെക്സ്റ്റ് ടോപ്പിക്, സ്കേലാർ പൊട്ടൻഷ്യൽ. Curlless or irrotational fields, that is curl of f is 0. If curl f is equal to 0, if del cross f is equal to 0, then f is called curlless or irrotational. കേൾ എന്താണെന്ന് നമ്മൾ പറഞ്ഞിട്ടുണ്ട്. സോ ഒരു വസ്തു കേൾ ചെയ്യുന്നില്ലെങ്കിൽ നമ്മൾ അതിനെ വിളിക്കുന്നത് എന്താണ്? ഇറ്റ് ഈസ് ഇറോട്ടേഷണൽ. ദാറ്റ്സ് ഇറ്റ്. del cross f equal to 0 everywhere. That means if a field f is irrotational, then del cross f equal to 0 everywhere. If del cross f is equal to 0 everywhere, then first condition, integral a to b f dot dl is independent of path. Second, closed integral f dot dl equal to 0 for any closed path. എങ്ങനെയാണ് നമ്മൾ ഈ ഒരു ഇക്വേഷനുകളിലോട്ട് എത്തുന്നത്? We have Stokes theorem, that is surface integral of del cross f dot dA equal to closed line integral of f dot dl. ഈ del cross f equal to 0 means closed integral of f dot dl equal to 0. Closed integral of f dot dl equal to 0 for any closed path means integral a to b f dot dl is independent of path. ഇതാണ് നമുക്ക് അതിൽ നിന്ന് മനസ്സിലാകുന്ന കാര്യം. Third point, f is the gradient of a scalar function. If del cross f equal to 0, then f equal to minus grad v. This is because curl of a gradient is 0. Del cross del v equal to 0. Now we have used a minus sign, which is purely convention. Now, the scalar potential is not unique, which means any constant can be added to v without affecting the gradient. In other words, grad v equal to grad v plus a, where a is a constant. Since the gradient of a constant is 0, grad v is equal to grad of v plus a. ഗ്രേഡ് ഓഫ് എ എന്ന് പറയുന്നത് 0 ആണ്. അതുകൊണ്ട് തന്നെ ഈ രീതിയിൽ എഴുതാൻ പറ്റും. അതുകൊണ്ട് സ്കേലാർ പൊട്ടൻഷ്യൽ നമുക്ക് യുണീക്ക് ആണെന്ന് പറയാൻ കഴിയില്ല. ഇറ്റ്സ് നോട്ട് യുണീക്ക്. നൗ വെക്ടർ പൊട്ടൻഷ്യൽ. Divergence-less or solenoidal field. If the divergence of a vector field is 0, or if del dot f equal to 0 everywhere, then we can call the field as divergence-less or otherwise solenoidal. Now, if del dot f equal to 0, then we can write the condition integral f dot dA is independent of the surface. Closed integral f dot dA equal to 0 for any closed surface. ഇതെങ്ങനെയാണ് വരുന്നത് നോക്കൂ. We have divergence theorem. According to divergence theorem, volume integral del dot f d tau equal to closed surface integral of f dot dA. For del dot f equal to 0 means this term on RHS will be equal to 0. So that is the condition 2. Closed integral f dot dA equal to 0 for a closed surface. That means integral f dot dA is independent of the surface. Now the third point, f is the gradient of a vector function. That is f equal to del cross A. If del dot f equal to 0, then we can write f equal to del cross A. This is because divergence of a curl is 0. Del dot del cross A equal to 0. Since del dot del cross A equal to 0, we can write f equal to del cross A. Now, the vector potential is also not unique, because a gradient del V of a scalar function can be added to A without affecting the curl, since the curl of a gradient is 0.